buddy.
All right.
It's time to start this review.
Good. I still have space left.
So the next couple days, we are gonna review for exam.
Yay.
And
My diary.
exam is over 2 days again, Wednesday and Friday.
Holy crap, I'm running out of paper.
Some of you guys can finish both parts on the same day, Wednesday. You'll be free on Friday. Some of you guys I know will take time and use both days, so that's fine.
God damn.
Any questions about the exam?
I got 22 pencils or something.
I said all chapters earlier, but no, it looks like the first chapter 1 and 2 wasn't on exam 2. So we're starting with section 4.3. So we don't have many chapters actually. 4.3, 4.4, 4.5, 4.6, only 6 sections. But the material is hard for some of you guys, I know. So it's a challenging chapter, only 4 sections there. And you'll be in good shape if you finish all these questions on your own without any kind of help. If you can finish them in a timely manner, then yeah, you should be ready. Okay? If you feel weakness and still hesitating on solutions, that means you need to practice on that subject more. Go to that section and solve as many as you can, okay? Alright, so I'm going to first survey all these questions. I'll give you time to think about them and you let me know which question to start with because we won't be able to finish all 21 on 2 days. Who knows, we may not. But I'll start with the ones that's challenging for you. So first 2 questions are basic exponential form change questions. You flip from logarithm to exponential form. These should take only 20 seconds if you know what you're doing, okay? And then these are opposite. There are exponential forms given. You flip them back to logarithm. You need to flip these to logarithms. Are you recording?
Yep. Yes.
Okay. Alright, on 5, 6, 7 there is no more flipping. You need to compute all these logarithms without any calculator, okay? Don't use calculators in any of these questions. You must be able to use the properties of logarithms, like if there is a matching base they cancel. Check this one. And you need to bring everything to powers, like 36 I think is a power of something. These are hints. Okay? And whenever you have a reciprocal 1 over something, you need to make it non-reciprocal. You need to flip both these questions, for example, some whole powers. A base raised to power only so you can get the results. There are actually 2 methods you can apply on these questions. We will talk about them if you need to, okay? This question is a domain finding question. As you know, logarithms do not work with all numbers. Only special values inside can be computed. And we are going to take a look at what x values make this thing working. And you need to change the interval notation. This is a good application. You have a chemistry exam, right? pH levels of any liquid can be computed by logarithm. Actually, it's computed by logarithm, so this is a nice application of it. Okay, we'll talk about this. All right, this is a big chunk of expression inside a logarithm. Guess what we are going to do? We are going to simplify this into pieces. There's a 1 logarithm. You're going to create sum and difference of logarithms, more than 1. And I think the next question is similar, same deal, just messier inside. It's no big deal if you know what you're doing, right? Well, it looks like I went back. Why am I going back? Okay. This one is opposite. There are 3 pieces of logarithms. You're going to make 1 big logarithm out of it. Alright, this one is computing a logarithm value, logarithm base 3 of a decimal. We've done a similar question in class, but it wasn't decimal. With the help of this example, there's an example here. And now we're gonna check back our solution is right or not with other steps. You're gonna solve this equation, exponential equations. There are more than one ways to do this. There are two ways actually. We'll talk about it. And this one is the same. Only here there is only one way you can do this one. Okay? There are multiple ways. Again, equation solving, exponential. We need to use some logarithms here to solve this. Actually, we done this, right? Last time? No. It was similar, not the same. No. Solve logarithmic equation this time, logarithms everywhere. We need to get one logarithm on each side or combine all logarithms into one. So you either bring all these three together and combine into one, or get one on the left, get one on the right, cross out the logarithms. There are two methods you can do. Interest question, we've done many. If you need to, we can still do this one. And this is we've done Canada's population with the same model. They just flipped the question story into number of computers infected by a computer virus. But that model, number of computers infected, is computed by this model or formula. It just asks us for several scenarios how the number is going to grow, what number is going to grow, etc. There are 4 parts. But if you recall, when we are doing this section 4.6, we solved a similar question with Canada's population. Alright, this is a similar problem. This time it's a population. I think we've done Ghana and Turkey's population. This time it's Thailand and Ethiopia. I just put pretty much the same question. We're just repeating it. If you need to, we can do this. But again, I'm leaving the questions easy, or you know very well, to the end, and we may not have time to solve them. Alright, this is maybe a new one. It's again investment finance question, interest question, but maybe a new version you haven't seen before. Okay, now you know all the questions. Which one do you want to start with? This one? This one or any other choice before? 2020? $20? How many say 20? 21? Okay, let's do 21 and then we go back 20. Yeah, so forth. Okay. This is continuous compounding. The keyword is continuous. Where is it mentioned? Interest is compounded continuously. So I won't be using we've been using this formula a lot. A equals P1 plus R over NNT. Nope, we're not gonna use this. This is for periodical compounding, like monthly, yearly, quarterly. This is what we use. Here it says continuous, and they even give us the formula, so you don't have to worry about memorizing it. PERT is what we are gonna use. So we are P dollar depositing. So initial amount is unknown. Initial amount is unknown, right? Do we know P? Is it given anywhere? No. So this is a question mark. And we did know a percentage, so what is this? In the formula, 3.3% interest compounded continuously is R. However, we do like IR in decimal value, not in percentage. So you need to change this quickly into decimal, which is 0.33.
0.33.
Yeah, I'm missing a dot, 0. this is the right formula. So when you're using it in the equation, that's what you need to enter. I see another data, 3 years. It looks like we're keeping this money 3 years in this account. So what is 3, 4 in this formula? T. So this is T equals 3. Okay. The amount in the account has earned 988.63. So I'm guessing this is the total amount in the account. So this is how much I have in the account. I will call this A, am I right? Is that the total amount in my account? No, that's not A. Usually in the past questions we were given A, we were asked to compute P or T or R. But here they didn't even give us the whole A. This is not A. This is only interest earned. Interest earned. So how much do I have in the account then? Whatever the initial amount plus this much you have. Hint says that already. This is your A. A is whatever you invested initially, after 3 years, this much more, that's the total you have. So why don't we substitute them that way? So in part A, they want to find out P, but they didn't give us A. It's okay. At least they gave us some partial A, which is P plus 988.63. This is A they have provided us. Again, this is A. And in PERT, we pretty much know everything except P. I don't know P. I do know E is a number. I do know R, which is 0.033. Times, we do know time, that's 3. Okay? Are we good so far? So who's our princess? What are we looking for? You're trying to save somebody. Who is that? P. We are looking to solve for. But they are in both spots, 2 spots. So we need to first get them together. Alright? And combine them. They need to meet each other. Alright, how about this number? It's an ugly monster protecting our P. But it looks ugly. When you punch in the numbers into your calculator, it's going to turn into a nice decimal value. Try that. Raise e to this power. Actually multiply 3 by this and raise it to the power of e. And tell me that number. What is that? Please, it says round to 1 decimal place, but give me a couple more digits so we can be safe. 1.104. Thank you. Alright, look, your question is a lot nicer looking now. P, princess you're looking for, added a number. That same princess you're looking for multiplied by a number. Okay, you have 1 apple plus 900 bucks, and you have 1 point some change apples. You're solving for apple or princess. So how do I solve this? No, that's a bad idea. Why? We always have a multiplier divided. Yeah, we've done this in the past, that's why you want to do that. But when I divide both sides with this number, yeah, this princess will get rid of the monster. How about the princess on the other? He's gonna get a new monster dividing it. So you're avoiding a problem here, but you're introducing another problem there. That's not good. Let's not divide. Back up, don't divide. Okay, let me ask you this simple question. You're confused by princess and that ugly number, but this is your question. How do you guys solve x plus 2 equals 2x. What do you do? I hear something. Why would you subtract 2?
Because you get x for itself on one side.
Alright, if I subtract 2, I just get 2 on the other side. This side is x. And still x is.
Subtract 2x.
Subtract 2x instead. Okay, that's a better idea. Or why don't you subtract x? Isn't this better? So when I do that, oh, look at this. You get x by itself. Okay? Now, why aren't you doing the same thing here? Instead of 2x, you have 1.01. So this is not 2, you have 1.104. 1.104x on this side, you have another x on that side, plus instead of 2, you guys have 900 something here. But I'm trying to show this complicated looking equation is actually as simple as this one. You have 1p here, a little more than 1p there. Why don't you subtract these and get number all by itself? So I'm going to subtract minus 1p from both sides. Minus 1p. This is also failing. Do you see it? Actually, this is what I want to do. I want to bring 1.104 to in front of p. 1.104 many p's. You have 1p here. Why don't we subtract 1p from both sides? And all you have on this side is 998.63. And on this side, what happens if you subtract 1 from 1.104? What is 1.104x minus 1x? You subtract these numbers, you get 0.104. Okay? Again, this is rounded off, all right? It's not exact number here. I know there are some more decimals here, which we don't care. Maybe we should. Just try to take as many as possible. A couple more maybe. I will test it. If this doesn't work, I will just add more digits, okay? Now, it's time to kill this monster by division because your princess is only on one side. Now it's safe. We can divide both sides. Okay? What is P? I'm not putting straight equal sign because this is rounded value, so you're getting a rounded value. What is 988 over 0.104? About 10 grand, right? What is it?
What is P? 9,506.06. That's rounded.
Like this?
Yeah.
They want how many decimal places? One decimal place. So I will round this into 1. Okay? 9506.1. Does it make sense? No? Are we good? All right. All right. Where did we mess up? First, let me compare. It's the same question. Yep. No, it's not the same. Yeah, it is.
It's 9,505. If you don't round the .104, it's 9,500. Instead of 9,506.
Okay. just take more digits on this, just to be safe. I warned you about it rounding too short. Give me more digits on this one. Actually, to be safe, do not round anything here. Just take this number as it is and subtract 1 from it. This is this mess, minus 1, dividing this thing. But anyways, let's just get a couple more digits. Do you have more, Garrett?
It's point 104, 0663.
663. If you divide with better digits like this, you get 9505.
No, 9500.
Just even nine?
Yeah,
Yep.
Okay. And no, how about the here? These?
nothing, it's 0.
0 zeros? Okay. It's just a rounding mistake. We can't avoid it if you start rounding in the middle, okay? Yeah, right on. Alright, now what are we doing in part 2? Now you know initial principle, right? You have 3 years before, you have invested $9,500 in this account. We're just asking how many years you need to wait to make it 13 grand, 13 and a half grand. Okay? There are two. Okay, it's asking from principal original. Already in 3 years, it's becoming about 10 grand and some change, 10,000, almost 500. I was gonna start from there, but we don't have to. Let's start 3 years before and count how many years to get that goal. So, again, we start part B with the same formula, PERT. A equals PERT. And our goal is to make 13 grand, right? This is how much you want after several years. But the starting value is 9,500. Rate is the same, right? All we need to find out is T. This is your princess. And we have done many questions like this. So there are a couple of months that are preceding T, before T, which is 9,500. There is a tower you need to demolish, and there is a guard waiting for T. So which one you kill first? Which one do you take care of these three things?
9,500.
Always the guy in front, right? You divide both sides by that. Okay. And if this is terminating, tell me what it is. If not, we have to put a lot of digits to be safe. What is 35? 135 over 9,005. Mm-hmm.
1.42105. Do you want all of it?
Just tell me two more.
26.
26. Alright, if you really want to round off really late, put more digits so you can be safe. But if I'm doing it with my hand calculations, I wouldn't round this up. Maybe you can just drop the first two digits, last two digits, divide by 100, 135 over 95. Even you can divide by 5, another 5. But I would just leave it like this to be safe. And then how do you demolish this tower? How do you take care of that base E? ln will do it, natural log will do it, right? So we take ln of both sides, cancel away these things. So I'm not going to compute this because another rounding up is going to happen and it's dangerous. I will wait. Now these two cancel and your princess is down with this guard. Now we need to take care of this guy by dividing it. Now divide both sides by this and T will show up. I think they want us to the nearest year. Is it nearest year? Yeah. Approximately how many years does it take? Just tell me a few digits here. Are you trying this? Do you have it? 10.608. But the nearest here is then 10, huh? Right?
That was 10.6.
Oh, 10.6. Alright, that changes the equation then. 10.6 becomes 11 then. Okay? You need to wait 11 years. Alright. Now I doubt it.
10.6, get around to 1 decimal.
But where does it say the 1 decimal? Oh yeah, it says in here. Sorry, I didn't see that. It doesn't say in part B, but it says earlier in part B, round to 1 decimal place, so it is 10.6. Okay. Row 8 is gonna be 1, so we're good, okay. Alright. Any questions? That was 21. Now go back to 20 next. But any questions on that one? Alright. There are 2 countries, their populations are estimated by, modeled by this formula. Initial population, growing with this part, e to the kt. Actually, t is number of years, e is constant, k is the growth rate, real growth rate. Since they are getting bigger, I expect a positive k. In part A, they want us to figure out k and substitute k back to equation, give us this formula more explicitly with k replaced by a number. You need to figure out k and put it right here. Okay? So here is what you need to do. Again, this is the measurement taken in 2000. This is 10 years after. 61 to 68, just like money growth. You have $68 from $61, E growth rate times how long? It's 10 years. You see 2010. So we're gonna repeat what we did in part B, right? A couple minutes ago, to get this Princess K this time. Rate is unknown. So here you go. I put $68 or 68 million is the new population. You deposited 61.4 million. E, rate is unknown. You can put R, but we technically call K in population computations. T, do we know T? We need to. If you're looking for K, it must be the only variable left. T is, what is it? 10. The time passed between 2 measurements, 10 years, 2000 to 2010. Look, identical steps. Although I'm not gonna round up in the mid steps. I will keep everything ratio. First divide these off. Take ln of both sides. And these cancel. And this is what you have. And k and 10 drops to ground. Divide both sides by 10. And all done. That's your k. Whatever this thing is. So let's calculate it. So again, ln of 68, what is it? Over 61. Take another parenthesis, please, to be safe. And then divide by 10. This is all you need to enter into your calculator too, right? 68 over 61.4 divided by 10, whole thing divided by 10. And that k is how many decimal values? 5 decimal places. 1, 2, 3, 4, 5. So I need to round up or down 9 up. So this is gonna be 1, correct? If you round 9 up. So 0.01021. Except the last digit will be rounded up. It's gonna be this. So you come and write the formula for Thailand as 61.4 initial population. E grows with this K, which is 0.01021 number of years to count forward from 2010. For Ethiopia, you're gonna repeat the same thing, exact the same thing. Instead of 68, you will take 70 here. Instead of 61.4, you will take 65.3. Do all this. I can do it in a second because I have my formula already here. So final year was 70.4, right? No, just 70. Initial year was 65.3. There you go. Is it over 10 year again? Yes. And this time, we round the 5th digit up this time. This is gonna be 0 and this is gonna be 7.007. Again, 5 becomes up, 95 becomes 100, so this becomes 700. 0.007. Do you see that? So the P model for Ethiopia is initial amount of population raised. Is that right? Is it double O one? Double O or single O? Double O. So which country has a bigger growth rate? Which one is bigger?
Thailand.
Are you sure this is 7, this is 1?
But it's
Looks
not
like
a
this-
0.
Yeah, this is actually 10, 0.01, this is 001, 10 versus 7. So Thailand is better, bigger, faster. Make sense? Please let me know if you miss a spot. I'm kind of fast because we've done the very same thing before. Okay? Let's check if we are right. What was it, last digits?
2, 1.
Q. T. This was 65.3. E raised to 0.07 T.
It was 2 zeros. Oh, I was on.
Thank you. Still incorrect.
I think you were supposed to round to 5 decimal places. I think you rounded to 4. Could be wrong on that though.
It says right there, right, 5 decimal place.
But we did. They want maybe, oh, 1, 2, 3, 4, 5. Oh, I should be rounding this one. Okay. Why didn't you warn me before?
I didn't know if I'd be wrong.
Oh, come on. Have more confidence. You're about to graduate this course. You know almost as much math as me. So 5, right? Good. See, you were right. I was rounding the 4th digit. instead of fifth one. Okay, so that was my mistake. All right, now we work hard and build an equation for each country. Now pick the fruits. What's the benefit of building such an equation? Now with using this equation, you can estimate any future population of any of these countries. Like Thailand, you want to figure out what's going to happen in 2020. All you need to do is flip something in this formula. What are you going to flip? What are you going to substitute?
20 T.
Yeah. T is going to be 20 years after 2000. Initial measurement is 61.4. You're going to put 20 more years to it and compute it. That's it. So does anyone have an answer? All you need to do is punch in these numbers into calculator. So there is some math involved here. Plug in this into calculator with T becoming 20. What is it? Anyone? I want to type this whole thing here. Oh, we still have something from past. Is it the same number? No, it's 0, 1, 0, 21. It's the same thing. Yeah, 20. Right? 75,310,000. What's the approximation required? Round to the nearest 100,000. 100,000. This is 75,300,000. So it needs to be 75,3 then. We round the next down. 0 is already 0. Am I right this time? 75.3 million. I need to enter everything else before checking it. So the next one is Ethiopia, and I need to flip this into, do you have the number? You still want me to do it, huh? 65.3, because I don't trust myself. This is 695, right? 75 even, because 0 is rounded down, right? Because this is 3, we round it down, 75 million even. Alright. And who has more people? Thailand, of course, 75.3, it has more. Why is this happening? Thailand was behind Ethiopia in 2010. How did they pass each other?
Growth rate.
Yeah, growth rate is greater, that's why. Okay? So which year is Thailand gonna hit 100 million? It's asking, this population will be 100 million, but what year? This is your process you need to solve. So you're pretty much gonna repeat this work. With K known, year is unknown. You will repeat this work here. But K is known now. What is K? Yes. 0.01021. T is unknown. How many years will it take to become that 100 million? Okay, we first divide each side with 61.4 like we did here, and take ln of both sides, ln cancels, and then ln 100 over, this is going to be a whole lot different of course. Now ln 100 over 61, this is k times t, 0.1021 t. We divide, instead of 10 both sides, with this k. And and get the t approximately, what is this number? Anyone? Divide this. Has to be more than 20 years. Because in 20 years you're already at 68, no, 75. Anyone? Okay. .4 divided by 0.0001. Agree? Here we go. 47 years. And it's gonna be 47 years after 2000, which is gonna be 2000. You will be inside 2047, several months, but it says which year you will be. Okay? For Ethiopia, you just need to flip these numbers into Ethiopia's number. So what was initial value for Ethiopia's? It was 65.3. And the rate is 695. For Ethiopia, it's gonna take a lot longer, 2061. Am I right, student?
I think so.
Okay. Good. That's it. Okay. So again, for Ethiopia, you're gonna enter initial population of Ethiopia 65.3 here, and Ethiopia's rate, which is 0.0, not this of course, 695. Right here, and get the T. All right. Next question.
39.
Good. I don't think I can finish this in 10 minutes,
we
but
do 11?
promise tomorrow we'll start with this one. Let's take a big, small, easier one. 11. Yeah, we can do this in 10 minutes. We're gonna separate this into logarithms, but where do we start? Such a mess. We always start with fraction. Do you see the division sign here, or quotient? Quotient, division, whatever you name it. You first split this logarithm into two pieces with quotient rule. What is quotient rule? I call it subtraction rule as well. This logarithm breaks into logarithm of something minus logarithm of something else. Tell me what comes here. What comes there? Anyone? Nate? No?
I think you're wrong, but would it be log of the top and then log of the bottom?
Yep.
Yes.
That's it. Top, bottom. What is top? That's 2x times x squared plus 7 to the 5th. What is bottom? Root 5 minus 3x. Alright, what is next? I believe we can still chop this up into pieces and this one into more pieces. I don't know. I have a feeling this can be done something about. I'm not sure about this one. Next. Alright, hint. What is this? What is it? A dot, red dot. times product. How do you separate logarithm of product?
Would be 5 log x squared plus log 2.
Yep, we separate this and that. You said times. So you put this dot here.
That's plus.
It's a plus, yes. Product turns into addition. Just division turn into subtraction, product turns into addition.
Is the 5 good front or not?
Yes, the next step is if you have a power around everything in a logarithm, that power can fly away to the ground in front of logarithm. That's the next step. Okay. How about here? Can you simplify this more? Yes. There is a secret product here as well. Can you split this into 2 logarithms as well? Yes, you can. It says as much as possible, and it's possible, and I'm doing it. All right. Let's work on this side. We ignored this side for a while. Can you do something here? Do we have a logarithm rule for square roots? You have 7 rules of logarithms. Any of them contains a square root symbol?
Do 1 to the 5th log of
Yes.
because there's a 1 over the x. Or 1 squared, 1 or 2. For the squared.
1 over 2?
Yeah.
Yes. There is no rules about radicals or square roots. Whenever you have a square root, we need to flip them into power. And also says this turns into this turns into power 1 over 2. So you have a power around that logarithm actually. Just like 5th power, you have stuff with power 1 over 2. Okay? Cube root, if this is a cube, it turns into 1 over 3. 4th root becomes 1 over 4. You always put 1 around this and divide by the index of the radical. Okay, what else can I do about this? Yep, just like 5 went outside, this guy goes in front. Oh, sorry, it's out. Fixed. Any more steps can you do here?
Can you put the left side in parentheses?
Which left side? This one?
Yeah. Like the entire, all of the additions.
Why do we need to put parentheses around this like this?
Yeah. That's what I did. I guess it's.
You don't have to, no, it's redundant, it's not necessary.
Okay.
If there is a number like in front, multiplying, yeah, you need a parenthesis, but if there is nothing, no, you don't have to. Not waste ink. How about this 2? Can you make this go away in front and combine with 5? Can I? No. This one won't escape because it's not the power of the entire stuff. It's just the power of x squared. So it can't come out. No. Oh, then can I separate this into 2 pieces, then let x squared, that square go? Like this? Can I separate x squared and 7 as this? Is there an addition law like this? No, there is no such addition law. You cannot separate additions or subtractions. This will not separate as well. No, only products or divisions, yes. So I think this is all. This is what you're going to enter in that box. 1, 2, 3, 4 logarithms. Any electrons you can combine? No. But we'll continue tomorrow.
Understood. Chemistry. I'm gonna chill in the light and in the back room. That is quite